In this demonstration, we're going to show how MQTT-SN can help you save messages over the air, and how the combination of MQTT-SN and the ThinkStream Data Flow Manager can help even further reduce the amount of data you're sending and save you power on the device. For the purpose of the demo here, I have a SARA R422 module, which has a built-in MQTT-SN client, making it really quick and easy to get up and running and sending data with MQTT anywhere. So I'm going to go ahead now and get connected. Here's my MQTT connect command. I'm going to send that now. Now I have an OK response back, and you'll see now the connected state of my R5 client has gone green. The next thing I need to do is register a topic that I'm going to publish to. So I'm going to do that now, registering the topic sensor/heat. I then get a response back from the broker giving me an ID for that topic to use. And now I'll go ahead and publish a message to it. I'll publish just a simple string message using a quality of service 0. That message is now being received on the broker, and now I can go ahead and disconnect because I'm all done. Let's have a look in the traffic logs and see what that looks like in terms of the number of messages that have been shared. So here we see I've got my connect, there's an acknowledgement back from the broker, registering the topic and the acknowledgement back, the publish of the message, and then my disconnects. So altogether there, 7 messages have gone over the air. Still fairly lightweight, but quite a lot of messages just to publish a message at quality of service 0 where there's no acknowledgement back from the server anyway. MQTT-SN allows you to send messages with a quality of service -1. And this means that you don't have to perform the connect in the first place. It also allows you to have topic aliasing. So let's just clear these logs out. Go and set up that topic alias. Here's my topic for sensor/heat from earlier. I'm going to add an alias now. The alias here is just a simple integer 114. Now, if I go back to my AT terminal for sending these commands in again, I'm now going to publish this message using the quality of service -1. I just need to update that topic ID to 114, which is the one I created just now. We're using a quality of service -1 that's indicated by the value 3 here in the AT command. So if I publish that message now, I'll immediately get an OK response from the client because it's not expecting a response from the broker. If I now look on my MQTT client traffic logs, here's my publish coming in at quality of service -1. So just a single message to publish that same message with the same effect, saving me a whole bunch of data over the air. Now that message that we published there was just a simple string saying what the temperature was. That data on its own is no good to any back-end system. It doesn't know where that message came from or what it's about, anything to do with it. So the way that you can work with that, still keeping the data on your device as low as possible, is by using flows. Let's go and have a quick look at this flow demo that I've got set up here. So this flow is just doing some really basic, simple stuff. There's a conversion of bytes to string, just so that I can read the payload easily in the flow manager. Let's have a quick look. We'll go back and we'll just republish that message again with the quality of service -1. And I'll see now in my flow on the debug, here's the message that's come in. And if I expand this out, I can see there's my payload, 23 degrees. Now, the broker and the ThinkStream platform obviously knows a lot more about this device. And I can see that down here in the message origin device part of the message object. And there's a whole load of metadata here that I can refer to, including things like the name of that device, any serial number that's been given to it, and so on. So let's have a look at how I can now use that data in the flow to send onto my back-end systems. So here I've got a simple JavaScript function node, which has been selected from the palette on the left-hand side here. And if we take a look inside, we can see just some simple JavaScript that saves off the original payload that I sent and builds a new payload as a JSON object, adding in the given name of that device and its serial number, and then pulling back in that original reading that I saved off. So let's connect that up, clear my output, save the flow, and now I can go ahead and publish that message again. Now if I look on my debug output, here's my original message that came in with that 23 degrees string on it. But now I've got a JSON object which has the device name, my serial number, and the value that came in for that temperature reading. So now there's more information for that backend system to know on whose behalf this data has come. So if I want to go ahead now and publish that out, I'm going to use the example here of an HTTP request. There's a number of other ways that you can get data out of the platform with some strong type nodes here for various AWS services. You could store data directly into DynamoDB. You can call Lambda functions or drop into an S3 bucket. And we also have connectors here for popular platforms like Microsoft Azure and IBM Watson, all of which can be very easily configured to send data out to your backend system. But for the purpose of this, we're going to use a regular HTTP post. For that HTTP post to take effect, I need to add some headers. So here I'm going to build in some headers to my message object with the content type. Imagine your backend system requires some kind of device level authentication. I can store a password for this device. So if we look here back on my things list, look at the properties for this device, I've stored a property of type password with a value in it. We can't see that value because obviously it's a password, so it's obfuscated in the UI for security reasons. But I can refer to that dynamically in my flow and use that for my HTTP post. Let's have a look at that in action. Connect that header node up, save my flow, clear out the output again. Now this time, rather than going back to my device and sending that message over the air again, I'm going to use a cool feature in the flow editor of replay last message. This allows you to resend the last message that executed in the flow, just to make it even easier for debugging and working on flows. You can even send test messages on behalf of a device, so you don't even need a physical device in order to work on your flow. So I'm going to hit replay last message now. Now I see the familiar debug output, and if I just scroll down and look, here's the piece of debug that relates to this part of the flow where the headers were added. Here I've got my new payload, which is the JSON object we built in the previous step. And now down in the headers section here are the headers that we've added. There's my content type, and now here's my password, my authorization header, which has been pulled back from that value stored against the device. And in my HTTP node here, that's just set up to do a post. It's posting to this test endpoint. And if I go and have a look at that, then I can see the data that's arrived. Here it is, the JSON object that was published. And here's my headers with my application type and my password ready there. So you can see how all of this kind of additional heavy lifting has been done on the server, where you have huge amounts of processing power available to you, leaving the device just to simply send just the raw data that it needs to, without having to add in all these additional bits of data, costing you more power and time and effort out where you're constrained in the field. So that concludes the demonstration. I hope you found it interesting. Thank you.